And let me start by sharing my screen. And as I share my screen, today is March 15th. We will be looking at inequalities and solving inequalities. This will be kind of the last of the new content. So all of the remaining homework for the chapter will be due on the 19th, which is Friday. And then between the end of class time Friday and the end of the day Sunday, you will be taking that test too on either Wednesday or Friday, depending on the time. We will go over a problem set / practice test for exam 2. Before we get started though, does anybody have any questions on homework 1.5 or 1.6? And I have to apologize, I just realized that I forgot to open that homework. And just remember that somebody sent me a question on one of the homework problems over the weekend that I thought was a great question. So if it's all right with you folks, I'd like to start class today by just looking at that one homework problem from 1.5. I think it was number 30. It's really a lot of fun because it mixed what we'd been doing with the rational equations earlier in the chapter with what we've been doing more recently, quadratic equations. So homework 1.5, let's look at question number, I think it was 30. No, it wasn't 30. Yeah, here's one, 35. Has anybody looked at, I'm sorry, 34 on question homework 1.5. Has anybody looked at that and had questions on it? If you're all right, just in terms of being able to save it, I'm going to take a minute and copy that problem into the start of the notes. We've got 1 over x squared minus 5x plus 4 is equal to 1 over x plus 4 plus 7 over x squared minus 16. Has anybody looked at that question like that yet in the homework?
Yeah.
Do you remember correctly when we were looking at these fractional equations, the first thing we said was, because it's an equation, they're easier if we can eliminate the fractions. And the way we did that was by finding the common denominator. In order to find that common denominator, we ended up factoring each denominator. This one would factor into x minus 1 times x minus 4. X plus 4 is first degree, there's no need to factor it. And x squared minus 16 factors into x plus 4 times x minus 4. So as I look at the list of factors, the common denominator would be the product of all of those factors, x minus 1, x minus 4, x plus 4. To that point, is everybody all right? So then what we had said we would do is we had said we would take each side of the equation and multiply it by that common denominator. And doing that multiplication on the left, I'd have that common denominator times my fraction, which is 1 over x minus 1, x minus 4. And in taking that product, the x minus 1, x minus 4 would be a common factor. And so that left-hand side stays x plus 4. On the right, we'd need to distribute. So I'd have that first fraction, 1 over x plus 4, times that common denominator, x minus 1, x minus 4, x plus 4. The x plus 4s would cancel, leaving me with x minus 1, x minus 4, which we saw was x squared minus 5x plus 4. And then we'd also have 7 over, well, that factored into x minus 4x plus 4 times that common denominator. The x minus 4, x plus 4 would cancel. So I'd be left with 7 times x minus 1, or 7x minus 7. So that would give me, simplify, x plus 4 equals x squared plus 2x minus 3. We want to start by making one side 0 because now this is a quadratic. Gives me 0 equals x squared plus x minus 7. And now we can go ahead and solve that resulting quadratic. As I go through my methods of solving, we could solve it, try to solve it by factoring, but I don't think there's a way that we could get factors of minus 7 to give us that one in the middle. It's not in the form where we have a perfect square on one side, so I don't think we'll be using the square root property. We could try completing the square, but again, I think I've told you folks that I think completing the square is a little bit more involved when that middle term has an odd coefficient. So I'd probably go ahead and solve this one using the quadratic formula. A being 1, B being 1, C being negative 7. And then we'd plug into that x equals negative b plus minus the root of b squared minus 4ac all over 2a. And from there, is everybody okay if I stop here, or do you want for me to finish this one? I just wanted to make sure everybody could follow the setup on it. Are we good, or should we finish it? Not hearing any complaints, I'm going to stop there. But then I want to ask, this was one from the homework that somebody had emailed me over the weekend, and I thought it was a great problem to go over with class because it combines what we had done with rational equations with what we're doing now, quadratic equations. Other than that problem, does anybody have questions on anything at all from the homework?
I do.
Go ahead.
I wasn't in class Friday. I sent you an email, but on 1.4, I had not understood 15.
Homework 1.4, question 15. Let's see if I can actually get there. Homework 1.4, question 15. Oh, that wasn't what I wanted to do. I apologize. I wanted to preview it. Wow, my internet all of a sudden is slow. You were asked to simplify. Here we've got 5 times the square root of negative 3 times negative 9 times the square root of negative 3. When you've got that negative under the radical, it's important that you put those in terms of I first. And so I'm going to think of this as 5 times the square root of positive 3 times I. And I'm going to multiply that by negative 9 times. To take the square root of negative 3, we factor out that negative 1 and get also the square root of 3 times I. To there, are you okay? So now multiplying 5 times -9 would be -45. The square root of 3 times the square root of 3 would be the square root of 9, which is just 3. And I times I is I squared. So that gives me -45 times 3 would be 135. And I squared is -1. And so my final answer here, multiplying the negative by the negative, would be positive 135. If you don't put it in terms of I first, you'll be off by a sign.
So what happened to that square root 3?
Well, over here, when I take the square root of 3, we can look at it in one of two ways. When I take the square root of 3 times the square root of 3, we could say when I multiply radicals, if they're the same index, I can multiply them, and I take the product of the radicands, and the square root of 9 is just 3. Or we can also say that when I multiply a radical by itself, it's like squaring the radical, and it undoes that square root. So the square root of 3 times the square root of 3, or the square root of 3 squared, would just equal 3. Better?
It'd be better if you, because my question was not the same square root numbers, so that's what confused me.
What were the numbers in the question that you had?
5 square root of -8 times -4 square root -10.
Okay, so did you put them in terms of I first? The square root of 5 times the square root of 8 times I times -4 times the square root of 10 times I. 5 times -4 would be -20. Square root of 8 times the square root of 10 would be the square root of 80. I times I is I squared. Are you with me so far?
Yep.
Okay, so now we got to simplify that square root of 80. What's a number that goes into 80 that's a perfect square? And not just any number, but the largest one. I think we can look at 80 as being 16 times 5. The square root of 16 is 4 square roots of 5. And so this becomes -20 times 4 times the square root of 5 times I squared would be -1. And from there, can I go on the assumption you're all right finishing?
No, because I wasn't sure if you multiply now -20 times 4.
Yep. Gives me -80. Square root of 5 is, oh, I take that back. Negative times negative would eventually become positive though, right? Because of this -1 here. So that gives me 80 square roots of 5.
You have a -1 there?
Yeah.
Oh, at the end. Okay.
Okay. So everything that's outside the radical gets multiplied. Those 3 multiply to the positive 80. And then the radical stays.
Yeah, it's all good.
Okay. Any other questions that anybody else had? On any of the homeworks? Not hearing any, I want to forge ahead then and look at inequalities. And I do believe earlier in the semester, we had a discussion of inequalities. We looked at the symbols less than, greater than, less than or equal to, greater than or equal to. And when we looked at those symbols of inequality, we also looked at that interval notation. And so if I look at that interval notation, let's say, for example, I have something like square brackets, -5, comma 3, rounded brackets. Does everybody remember that in that
Solid on the left.
solid, if I were to graph it, I'd have a solid dot on -5, an open dot on 3, and I'd shade in between. Or I could say that -5 is less than or equal to x is less than 3. Instead, if I just had, let's say, -infinity, comma 1, and let's put a solid bracket there. Does everybody remember that we'll always have a soft when it's positive or -infinity, and it means there isn't a lowest value. It keeps getting more and more negative. It tells us our largest value is 1, and because it's solid, it would be like having a closed dot on 1. And so that would be like saying x is less than or equal to 1. Instead, if I had something like a soft parentheses 2, comma infinity, again, it will always be soft on positive or -infinity. That means there is no largest value, so that inequality will keep on going to the right. Because there's a soft bracket, it would be like an open dot on 2. And so this would be like saying x is greater than 2. Or if you wanted to, we could write that as 2 is less than x. Does everybody remember working with these interval notations at the beginning of the semester?
Yeah.
Then, in addition to working with these interval notations with inequalities, we had also talked at the beginning of the semester a little bit about set operations. And with set operations, we talked about the intersection. And we had said that the symbol for intersection was kind of like this big, bold, upside down U. And the intersection was what was common to both sets. What's common to both? Or where they overlap. As opposed to the union, which was that same oddly shaped U, but this time right side up. And the union was combining all of the elements from both. I'm sorry, there should be an E at the end of that word combine. And so does everybody remember at least hearing those two words early on in the semester? And so, for example, if I were to take the interval open at 0, closed at 7, and intersect it with the interval closed at 4 to infinity, there's a couple of ways of finding these. I think for a lot of people, it's easiest if you can visualize it. And so I like to sketch the first interval. And so the first interval would be going from 0 to 7 and everything in between. Then below it, I like to sketch the second interval. The second interval would be, let's see, probably want to put that 4 somewhere between 0 and 7. And it doesn't stop. So it keeps on going to the right. And then what I like to do is I like to find the intersection is the overlap of those two intervals or what they have in common. And so what they have in common would be everything from 4 to 7. This one includes 4, this one includes 4, so we'll include 4. This one includes 7, so this one includes 7. So they both have the 7. And I'd have everything in between. So that would be my number line sketch. Or interval notation, it would be the closed interval from 4 to 7. And I think I vaguely remember doing a couple of these intersections and unions at the beginning of the semester. But let's just try a couple more. Does everybody have this sound? Are you all right if I turn the page?
Nope.
So I'm going to ask you folks to find the intersection of the closed interval from 1 to 10, intersect the fully open interval from -3 to 4. Did anybody else get the half open interval closed at 1, open at 4? And again, it's a matter of personal preference. If you want to use the closed dots on a number line, you can. Instead, and open dots on the number line, instead of closed dots, some people also draw those square brackets. And instead of open dots, some people draw those rounded brackets. Is that one all right for everybody?
Yeah. What is the reason? Like, what's the difference between the closed and open?
If it's closed, this would, if it's closed over here, this first one is telling me that 1 is less than or equal to X is less than or equal to 10. And it's okay to equal those endpoints. Over here, when it's open, it's saying that -3 is strictly less than X is strictly less than 4. And so if the dot is colored in, if it's closed, I'm saying that I am including that value. Or if it's a squared bracket, I'm saying I am including that value. Instead, if it's an open dot or a rounded bracket, it says I'm getting as close to 4 as I possibly can. Or on the other side, I'm getting as close to -3 as I possibly can, but I'm not including it. And so when I look at the intersection, the overlap, since I've got a closed dot at 1 here, and since my number line obviously includes 1 here, I'm going to include 1 in the intersection. However, over here, in the second one, I'm going up to 4, but not including it. And since 4 isn't included in that second number line, it won't be included in the intersection. Any better?
Yep.
So then let's look at a couple of these. When I look at the union, I include everything from both. And again, I can go through and look at doing these with number lines. If I have the closed interval from 1 to 10, and I want to take its union with the open interval from -3 to 4. Well, again, if I take that closed interval from 1 to 10, I'm including 1, I'm including 10, and everything in between. If I take that open interval from -3 to 4, I'm sorry, that's a 10, by the way. I'm not including the -3. I'm not including the 4, but I am including everything in between. But now here, when I take their union, I'm combining them, I'm putting them together. I'm not just taking the overlap, but I'm taking everything from both. So the lowest I'm going is -3, but I'm still not including it because it wasn't included in this set. I've got everything in the overlap. And then the highest I'm going is 10, and I can include the 10 because it is in that first set. And so this would be the half open interval, open at -3, closed at 10. And so here I'm not just looking for overlap, but I'm looking for everything from both combined. Sometimes with unions, if I have, let's say, for example, the interval from -1 to 3, union the interval from 4 to 10, written like that. That first one goes from -1 to 3. That second one goes from 4 to 10. They have no overlap, they have no intersection. But when I take the union, I want to take everything from both. So I'll take -1 to 3, 4 to 10. And when I put them together, because they don't have any overlap, I'm going to just have to leave that as -1 to 3, union 4 to 10. Does that one make sense, folks?
Just 1 second.
Sure. Let me know when you've got it. Right?
Yeah.
What we're going to look at today is not just representing inequalities on number lines and looking at their unions and intersections, but we're going to start solving inequalities.
So was that just no solution, or
No, your solution,
that's just your answer?
this is your answer.
Okay.
And solving inequalities in some ways is similar to solving equations, And in other ways, it's different. And I don't remember if we went over the properties of inequality last time, earlier in the semester. So let's just real quick review them. We have the addition and subtraction properties. Which says that if I have an inequality, if A is less than B, then I can add the same thing to both sides and the inequality remains the same, or I can subtract the same quantity from both sides and the inequality remains the same. So if you add or subtract the same quantity to both sides of an inequality, the direction of the inequality remains the same. And so if I'm adding or subtracting with an inequality, it's very much like with an equation. However, you want to make sure you keep that symbol of inequality in between so that you maintain that direction. So over here, if I wanted to solve this inequality for x minus 7 is less than 1, I want to get the x alone. So the opposite of subtracting 7, I'd add 7 to both sides. So that gives me x. The direction of the inequality remains the same, and I get x is less than 8. Again, the largest value would be 8. I'm not equaling 8. There is no smallest value. So that would be the open interval from negative infinity to 8. Another example, let's say I have x plus 9 is greater than or equal to 15. Well, here, to solve for x, to get the x alone, the opposite of adding 9 is subtracting 9. Again, I want to do the same thing to both sides, so I'm keeping that equal sign in between. X plus 9 minus 9 would be x. 15 minus 9 would be 6. But the direction of that original inequality remains the same because I'm adding or subtracting. And so we get x is greater than or equal to 6. The smallest value would be 6, and there is no largest value. So we have that interval closed at 6 and to infinity. Are those all right?
Yeah.
Where inequalities, solving inequalities differ from solving equations is when I look at multiplication and division with inequalities. And so I'd like to start by looking at an example to justify this rule. And I apologize, I don't remember if we went through and did these steps earlier in the semester, but I think they're important. It's important enough to see, to help you remember why the rule holds, that even if we did it, we'll look at the idea again. Let's say -3 is less than 1. Is everybody all right? A negative is less than a positive. Now, if I go through and multiply both sides by, let's say, 2. On the left, I'd have negative 3 times 2. On the right, I'd have 1 times 2. And that would give me negative 6 and 2. And you notice that that negative number is still less, negative result is still less than the positive result. However, if I started with that negative 3 is less than 1, and I multiply both sides by negative 2, well, when I take negative 3 times negative 2 and 1 times negative 2, here on the left, negative times negative is positive. Here on the right, positive times negative is negative. And now we're comparing 6 to negative 2. And positives are greater than negative. So if you see, do you see that if from the example, I multiply or divide both sides of an inequality by a positive, it remains the same. Gosh, I'm sorry, I cannot spell worth beans to D. Positive. It remains the same direction. But if you multiply or divide both sides of an inequality by a negative, the direction is reversed. So if we add or subtract the same thing to both sides, the direction always stays the same. If we multiply or divide by a positive, the direction stays the same. But if we multiply or divide by a negative, that direction is reversed. So let's go through and let's look at some examples. Let's solve each inequality and write the answer in interval notation. Let's start with 2 times parentheses x plus 4, close parentheses, is greater than 3x minus 5. In order to solve this inequality, we want to start by simplifying each side as much as possible. So on the left, let's distribute that to 2x plus 8 is greater than 3x minus 5. And now we want to isolate the x. We want to get that x alone. In order to do that, you have a choice. Would you rather subtract 2x from both sides and move the x to the right? Or would you rather subtract 3x from both sides and move the x to the left? Does anybody have a preference?
The 2x.
So let's subtract 2x from both sides. Because we're subtracting the same thing, our inequality stays in the same direction. So that gives me 8 is greater than 3. I'm sorry. Let's try that again. 2 minus 1 is not 3. I'm sorry, 3 minus 2 is not 3. 3 minus 2 is 1, minus 5. Now to get that x all alone, we'll add the 5 to both sides. And again, we're adding the same thing to both sides, so our inequality remains the same. So that gives me 13 is greater than x. If I wanted to picture that on a number line, 13 is greater than x. So the largest value would be 13, and I'd be taking everything to the left. So it would be the interval from negative infinity to 13. And I apologize, we're not including that 13. It wasn't
Right.
less than or equal to, it was strictly less than. So that should be a rounded bracket. Everybody all right with that one? If so, then let's try one more. And let's have you folks do this one. I'm going to be quiet for a minute and give you folks 7 minus 3x is less than negative 2. Did everybody get the interval from 3 to infinity that x is greater than 3?
What makes us know that we flip it if you divide?
If you multiply or divide by a negative.
Okay.
And it's most basic. Recognize that if I'm dividing by a negative, I'm changing that sign. That's why I change the sign on both sides of the inequality first. Okay, multiplying or dividing by a negative reverses the direction. And so where all of this comes into play, we're going to start looking at solving first compound inequalities. And a compound inequality is an inequality that has not just 2 parts, but 3. So an example of a compound inequality might be something like negative 8 is less than or equal to 6 minus 2x is less than 12. And when I go through and I look at solving these compound inequalities, what I want to do is I want to isolate the variable in the center. And so I want to end up with an inequality, where x is in the middle. And so in order to isolate that x in the center, I'm looking over here and I'm saying to get that x alone in the center. First, let me use my addition property of inequality to get the x term alone. So I would add -6. And what I do to any part of the inequality, I have to do to all 3 parts. So add or subtract the same quantity to all 3 parts of the inequality. And so that would give me -14 is less than or equal to -2x is less than 6. And then, in order to finish this, to get the x all alone, I'll multiply or divide the same to all 3 parts of the inequality. Here, to get the x alone, I'd have to divide by -2. But you have to, again, remember to change direction if it's negative. And since I'm dividing by -2, here I get +7. I'd have to reverse that from less than or equal to greater than or equal to. Negative divided by negative would be +1. 6 divided by -2 would be -3. And I'd have to reverse that direction from less than to greater than. And so this would be my final solution. X is between -3 and 7. It cannot equal -3. It can equal 7. And so in interval notation, it would be that half open interval, open at -3, closed at 7. Questions? Shall we try another 1 or 2 of those?
Sure.
Let's ask you folks to solve. Let's say I have 7 is less than x plus 5 is less than 11. And I'm going to be quiet for a minute and ask you folks to please try that one.
There's just one step to that.
Subtracting
Okay.
5 from both sides. We'd get 2 is less than x is less than 6. And so we'd be 2 is the smallest value, 6 is the largest, and we're not equal to either. That one all right.
Yeah.
Let's try one more. This time, let's have you folks please solve -6 is less than or equal to 1/2 x minus 4 is less than -3. With this one, because we have that coefficient of a half, we could think of dividing each by a half. Or again, remember, sometimes with fractional coefficients, it's easier to think of multiplying by the reciprocal. And the reciprocal of a half is 2. And because it's a positive 2, all of our inequalities will remain in the same direction. So we get -4 is less than or equal to x is less than or 2. We're including -4, it's the lowest value, and we're not including 2, it's the greatest value. How was that one for everybody? Did you remember that if we have a fractional coefficient, it's easier to multiply by the reciprocal than it is to divide by the fraction? And again, because that's a positive 2, our inequalities remain in the same direction. So far, so good? Not hearing any questions then. The next place that we're going to go is we're going to look at absolute value inequalities. And when we look at absolute value inequalities, we're going to look at 2 different types of inequality. First, I'm going to see what does it mean if the absolute value of x is less than 2. Well, if the absolute value of x is less than 2, I think it's obvious that x would have to be less than 2. It has to be a number less than 2. But I don't think it's all numbers less than 2. Let's say, for example, I ask, what if x is -3? -3 is less than 2, but if I take the absolute value of -3, that's not less than 2. And looking at this idea, does it make sense that if the absolute value of x is less than 2, it means that x can be less than 2, but it has to be greater than -2. It's kind of like that idea that we had said absolute value is like the distance from the origin. And so if I say that my distance is less than 2, I can go 2 on one side, and I can go 2 on the other side. And so that would take me from -2 to 2. And so I'm going to say, in general, to solve the absolute value of x is less than a, we're going to solve -a is less than x is less than a. We have to solve that compound inequality. Does that make sense, folks?
Hang on.
Did you say okay or hang on?
Hang on.
Okay.
All right.
So let's look at an example. Let's first look at something like the absolute value of 3 times parentheses as x minus 1 plus 2 is less than or equal to 20. Does it make sense that we're going to simplify as much as we can first. That gives me the absolute value of 3x minus 3 plus 2 would be minus 1 is less than or equal to 20. We want to make sure that the absolute value is alone. Which it is. And so now, if the absolute value is less than a quantity, we're going to rewrite as a compound inequality. So that gives me that 3x minus 1 can be less than or equal to 20 or greater than or equal to negative 20. And we'll solve that by trying to get that variable alone in the middle of the compound inequality. So here I add 1 to all 3 parts of that inequality, giving me negative 19 is less than or equal to 3x is less than or equal to 21. And then to get the variable all alone in the middle, we need to divide by 3. And again, we have to do that to all 3 parts of the inequality, giving me negative 19 thirds is less than or equal to x is less than or equal to 7. And again, we've got to make note of the fact that that 3 that we divided by is positive, so that the direction remains the same. And so closed inequality from negative 19 thirds to 7 would be my solution. That one all right?
Yep.
Next example, let's look at the absolute value of 2x plus 6 over 3 plus 1 is less than 3. I'm going to leave what's inside the absolute value bars alone and first try to isolate that inequality, get it, isolate the absolute value, I apologize. And so I'm going to subtract 1 from both sides, which is going to leave me with the absolute value of 2x plus 6 over 3 is less than 2. Now, because my inequality is a less than, I'm going to change it into that compound inequality. Negative 2 is less than 2x plus 6 over 3 is less than 2. Now I want to solve that. And again, I would probably try to clear the fraction first. The only denominator that I see is 3. So let's go ahead and let's multiply each part of that inequality by 3. It's a positive 3, so my directions stay the same. Negative 6 is less than 2x plus 3 is less than 6. I'm sorry, that's 2x plus 6, I apologize. Now I'm trying to solve for x and try to get the x along in the middle of the compound inequality. I'll subtract 6 from all parts, giving me negative 12 is less than 2x is less than 0. And then to get the x all alone, I'll divide by 2. It's a positive 2, so my direction stays the same. I have 1x in the middle, and I get negative 6 is less than x less than, well, 0 divided by 2 is still 0. And so again, these would be open intervals. The smallest value is negative 6. The largest value is 0. So far, so good. So if I'm solving where an absolute value is less than a given quantity, I'm going to rewrite that as a compound inequality. What if the absolute value of x, instead of being less than a number, is greater than a number? For example, what if I have the absolute value of x is bigger than 2? Well, I think it would be obvious that x can be any number greater than 2, 3, 4, 5, and so on and so on and so on. But I think we need to include a little bit more. If we look at that definition of absolute value as being the distance from 0, if I want everything that's further than 2 away from 0, I could get all of those numbers bigger than 2. But in the other direction, couldn't I also get all of those numbers smaller than negative 2? And so to solve the absolute value of x is greater than 2, we say that x can be greater than 2, or x can be less than negative 2. And or is like taking the union, combining the two. And so we'll say, in general, to solve the absolute value of x is greater than some quantity a, we get as our solution x is greater than a, union x is less than negative a. And so for greater than, we need to solve 2 inequalities. We're going further from 0 on either side. So let's solve each of the following and express the solution set in interval notation. And so let's say we've got 4 plus the absolute value of 3 minus x over 3 is greater than or equal to 9. Again, before I rewrite it or do anything else, what I want to do is I want to get that absolute value alone on one side of the inequality. So let's go through and isolate the absolute value. Which means this plus 4 will subtract 4 from both sides. And that gives me that the absolute value of 3 minus x over 3 is greater than or equal to 5. And now, because it's greater than, we're not going to turn it into a compound inequality, but we're going to rewrite it as two inequalities. For one, we just lift the bars. 3 minus x over 3 is greater than or equal to 5. Or for the other, we lift the bars, change the direction, and change the sign on the other side. Now, I know that when I first started learning these, gonna fess up to you guys, I got a little bit confused because I know that with one, we solve a compound inequality, and with the other, we have to break it into two inequalities. Well, the way this is written, if I were to try to make that compound inequality, wouldn't that compound inequality have left, we would have left this part we keep, and this part we change the sign on. And as I look at that, do you see that right now we're saying that -5 is bigger than 5, and that doesn't make any sense. And since that does not make any sense, I do need to break it into those two separate inequalities. I don't know if that helps anybody or not. I do remember that line of reasoning helping me determine that when it's greater than, I've got to make two separate inequalities, as opposed to when it's an absolute value less than, I can treat it as a compound inequality. Now to solve, I'll subtract the 3 from both sides in the first, giving me -x over 3 is greater than or equal to 2. And now here, to get the x alone, wouldn't I have to multiply both sides, not just by 3, but by -3? And because I'm multiplying by a negative, I change the direction. And that gives me x is less than or equal to -6. On the other side, when I subtract 3 from both sides, I get -x over 3 is greater than or equal to -8. And again, to get the x alone, I'd have to multiply both sides, not just by 3, but by -3, because I want to get positive 1x. And again, when I multiply by a negative, I change the direction. And so that gives me that x is less than or equal to -24. Wait a minute, what did I do wrong here? This one should have been a less than. And then when I reversed it, it should have become a greater than. I think I scrolled up and I lost my original inequality. And so I get x is less than -6. -6 is the largest value. There is no lowest. Or we'd be taking the union of x is greater than -24. -4 is the smallest value. And there is no upper limit. And so this one would be the union of two disjoint inequalities. Do we have time for one more? Or shall we stop here for today?
I think
Can
no more
you
math.
go up a little bit?
Say that again. I heard two different people talking at once, and so I didn't hear either of you.
Can you go up a little bit?
Oh, sure. All right, and so if we're not done with this one, I am going to.
Wouldn't negative times negative be positive?
You're right.
That's where I was getting messed up.
I apologize. Thank you for correcting me. And so I'm going to make note that we stopped here. And we'll pick up from here next time. And I promise next time I will get all of the typographical errors out before class begins. I apologize. Let's stop sharing, stop recording. Any questions?